Hey guys, welcome back to the channel. I hope you're doing well. So today we'll be going to solve the all the things spanning tree problem. Okay, we just need to count the spanning trees, all these things. Okay, within the given and the connected undirected graph. And let's see how we can calculate. So this is the sample example. Okay, and the one way coming to my mind is we can calculate a given graph. Okay, it's spanning tree or not. Okay, so that we can do, right? So if somehow we provide the graphs, different graphs, and check is it a spanning tree or not, that way we can count, right? For example, in one case we can pass all the edges and check is the spanning tree or not. If yes, then our count will be 1. Okay, from 0 to 1. Then we pass other edges. Okay, for example, just remove this one and pass these two and check spanning tree. If yes, then count 1. And similar with these two, like we need the combinations of the edges. First the 0th edge, like 0 1, and let me put these edges here. Okay, 0 2 and 1 2. So we have to make the combinations of these three edges and pass to this function which checks is a valid spanning tree or not, and if yes, then we can count it. Okay, so this is the first brute force approach that coming into my mind, but obviously it takes a lot of time. We need to get the combinations of all the edges, right? So currently we have three edges, so the combinations will be like 2 to the power 3 minus 1 from 0 to, right, basically 2 to the power 3 combinations. So if the edges are, if the vertex are too many, then let's see how many vertex we have in the, so it has 10, so probably 2 to the power 10, which is obviously a bigger number. So we can reduce this with a simple technique, which is I forgot the algorithm name, Kirchhoff something, I'm not sure, but what it does is it creates the matrix. Okay, and put the content into it, and then we just need to find the determinant of the matrix. Okay, so I will teach you, I'm just giving an overview what we are going to do. So let me check what's the, you know what's the name of that algorithm. I think it's a Kirchhoff something. uh, okay, right, Kirchhoff something. It's a law but not uh, mm, algorithm. Let's see, algorithm, right, this is the name. It's a matrix tree theorem. Okay, and let me show you quickly what it does. So let's say we have these edges, right, and now we have to create a matrix of this size. Okay, 3 cross 3, which is the vertex, right? So let me create 0 1 2 0 1 2. It's a 3 of 3 size, right? And then we just need to put the content into it, and the content is like, if let's say this is 0 1 2, these are connected, right? So if there is edge between 0 to 1, then create, to put minus 1 into this matrix, like 0 to 1 minus 1. Similarly, this is undirected, so there will be edge 1 to 0, right? So put minus 1 like this. So, and if there is no edge between 0 to 1, then simply put 0. And we are not going to fill the diagonals. Okay, these diagonals we are going to fill, but not right now. So put the minus 1 minus 1 minus 1 because we have the edges, right? And in the diagonal we have to put the degrees. Okay, degrees in the sense how many edges for this vertex. Okay, for example, for the 0 there are two edges, incoming or outgoing, right? So put 2. Similar for 1 it's 2, and then it's 2. So once we fill this matrix, okay, then we just need to calculate determinant of, remove any one column or row from this particular matrix. For the simplicity, let's remove the 0th row and the 0th column. Then if you calculate the determinant of this remaining matrix, then this will be the answer. Okay, so for the 2 minus 1 and 2, how we can calculate the determinant? It's pretty simple. Let me write the formula here: a, b, c, d. Let's say this is the matrix, and for the determinant, the formula is like, let's say the matrix is a. Okay, so the determinant of a will be like a, sorry, a into d minus c into b. Okay, this is the formula for the 2 cross 2. And if there is only one in the matrix, let's say a, so simply return this a. But let's say if the matrix is 3 cross 3, okay, 3 cross 3, a is like a, b, c, d, e, f, I, j, k, let's say. Okay, and the formula will be like, first pick this. Okay, the formula of determinant of a will be like a into the remaining matrix. Okay, which will be this one, the determinant of this one. Okay, so the determinant of, let's put e, f, j, k. Okay, minus, then pick this one, the second uh, item from the first row, and into the determinant of these d, f, I, k. So we just simply not considering the items that are present in this row and this column of that number. Okay, so if we pick b, don't pick the elements from the row in which b contains and the column in which b contains. Okay, so and also first we take plus, then minus, again plus, then again minus, and so on. Okay, so after b it's a term of c, right? So c into, and for the c it's plus because in the previous it was minus, so we just alter the signs, right? Then b, so we going to exclude the all contents present in the cth row and the cth column. Okay, this third column, so the remaining will be this one, right? And since we get the 2 cross 2 again, so we can apply this formula, right? So this is the recursive function. Okay, once you see the code, it will be easy for you. And if you remember that we are keeping the 0th row, okay, constant, and changing the item, okay, the columns, 0th row constant and the column is changing, right? So we are taking only 0th row items here, right? So if the matrix is 4 cross 4, then again we put the into the 3 cross 3, then again the 2 cross 2, and then we get the answer, and then we pass the answers into for these, right? So like this way. Okay, not more no more confusions. So let's see the code now. This is the determinant, so currently I'm just ignoring it. Okay, we'll I will explain it later. First, let's see if the vertex is only one, then there will be one spanning tree. Otherwise, create this matrix. Okay, the Laplacian. Okay, whatever the name you can even put here. Then from u to v or v to u, it's minus one. Okay, and for the diagonals, what we can do, we can check how many edges, either incoming or outgoing. So for this one, if you want to calculate the incoming edges, so we can directly calculate how many minus ones that this contains. So that will be our right degree, because from 0 to 2, that is why we put here minus 1, and there is another connection 0 to 1, that is why we put minus 1 here also. So we just need to calculate how many minus 1 we have in the row, and that will be the degree. So yeah, that is why we are calculating this, and this is putting the degree for the diagonals, right? And then uh, as I said, just remove this first column, first row, and the remaining matrix determinant will be the answer. So we are passing this matrix and decreasing the size, and this will be our the answer. Okay, so now if the size of the matrix is 1, then the answer will be whatever the contains, and if it's 2, then remember uh, this one is a and this one is b, right? 1 1, and then 0 1 and 1 0, and this one is minus since it's only 2. And if it's not size 2, probably it's 3. Then again create a temp decreasing a size, because uh, if you remember this 3 cross 3, again we are just calling, we are just need this 2 cross 2 matrix for the calculation, and these first rows items will be considering into the answer. So that is why it's size minus 1, and since we need to create another, we need to pass this matrix for the determinant calculation. So what we do is put the a here, and the content of e f g h we need to fill in this temp. Okay, like e f g h, like this way. So that is why we creating another loop which starts from 1. This is the second row by the index wise, and we are gonna getting the all content, the columns from 0 to the size. And if the column if the that column, okay, for example, we this is the temp we get. Okay, so we need to calculate the determinant of this, so we are passing size minus 1. That is why it's creating the temp of 2 cross 2. Okay, and since these columns, the first row columns, we are continuing into the answer. That is why a, which is the first column, okay, the 0th column, and then what we are going to do is put this content, right, e f j k, into this table. So we are getting new variables, let's say I and j, which will be tracing these 4 elements. So first I will be starting from the 0th, and if it's the column, then ignore it, because we don't want to include these elements. That is why we are ignoring it. If we are on e, then simply we are going to put that into the element and plus plus. If the column reaches the size, then again we just need to increase the, move to the next row and column again 0, and this is how it works. And once we calculate this matrix, then again pass to the recursive call with size -1. And remember, as I told, it's a plus minus plus minus. So if the column is even, then it's plus, otherwise odd. Because let's say this is the 0th column, then 1th column, then 2th column, right? So -1 will be for the odd columns, right? So that is what we are doing, and at the end, returning the determinant. I hope I am able to understand. I am able to explain the determinant. If not, then please uh, check out any other videos on the YouTube for the determinant. Okay, and that's our answer. I hope ये अभी run हो जाए. Okay, so let's submit. So yeah, it's working. Thanks for watching.